Hi, welcome back to our Road to Steam series, a series in which we'll be creating a game from scratch. Previously on our HEUSS Dev Diaries, we implemented hit effects to our combat animations. In today's episode, we're creating a blood splatter effect. Interested to follow the progress of our game? Make sure to subscribe and hit the notification bell to get all the latest development updates every week. It's finally time to implement blood inside our game. However, because of the complexity of this effect, we'll separate its implementation into 3 different videos to assure its quality. In today's episode, we'll focus our attention on the implementation of the overall system. This encapsulates how the blood gets emitted, and how it interacts with the environment. It'll be a more technical devlog where we'll break down the different techniques we use to accomplish our blood effect. For our next episodes, the focus will be put on the art side of things, and the implementation of the effect inside our combat loop. So without further ado, it's time to get bloody. Blood is a really important part of the presentation in HEUSS. From a young age, we always were obsessed with blood in video games. For us, it's one of the single best way to provide instant visceral feedback on the action you're performing on screen. But just having it spray all over the place is not enough in our opinion. We want it to splash on the ground to reflect the intensity of the battles you just fought. If the battlefield isn't painted in red after your passage, then it means that more blood is needed. To bring this vision to life, we devised a system that's separated in 3 stages. First, we have the emission phase. With this step, the goal is to create the blood particles in question, and make them travel realistically through space. When these particles come into contact with the ground, we enter the second phase of the process. In this one, our purpose is to gather all the information we need on the colliding particles once they make contact. This intel will become crucial as we transition into the last stage of our system, the splattering. In this final step, we paint the blood particles on the ground based on the prior information we gathered on them. This will allow us to create a splatter effect that realistically follow the behavior of our blood particles. With this out of the way, let's dive into the nitty-gritty, and see how it's implemented inside the game. First, to realize the emission phase, we'll need the help of particle systems. Like we explained in an earlier episode, particle systems are used inside Unity to instantiate and manipulate particles. These particles can take a 2D or 3D form. For our blood effect, we'll use 2D sprites to bring it to life. As today's focus isn't on the art side of things, we'll take advantage of placeholder images as our blood sprites to save on time. We feed our system this particular sprite, and start emitting particles in a cone-like pattern. But to really make this effect feel like blood, more tweaks are needed. First, we add gravity to our particles. Something heavy to create a feeling of viscosity. Then, we specify a random start size and duration once they get instantiated. This will create variation in their appearance, and the amount of time they stay alive. To further increase this effect, we'll make them shrink over their lifetime. For our next modification, we'll squash and stretch our sprites in the direction of their velocity. We accomplish this by using stretched billboards, which bend the particle depending on its movement. A great trick when you want to create a more liquidly effect. As a final touch, we apply a random transparency value, and a random darkening effect to the color of our sprites. This will allow us to differentiate them when they are all clumped up together into a single group. With that done, our first phase is officially complete. For the second phase of our plan, we'll need to stop our particles from going through the ground. To accomplish this, we'll take advantage of the collision component of our particle system. This component allows particles to interact with colliders around the scene. We make use of this by creating a collision box, and aligning it with the edge of our ground panel. In addition to stopping particles, this handy barrier also provides us with useful information every time a collision happens. Things like the position of the particle, its current lifetime, its size, its color, which particle system it belongs to, etc. With all this important data right at our fingertips, we have everything we need to create our splatter effect. To implement the final stage of our system, we'll instantiate our placeholder splatter every time blood collides with the ground. When a specific particle comes into contact with our collider, the blood splatter sprite is created at the exact position of the collision, and in front of the ground panel. After that, we manipulate our image with the information we gathered from the impact. We adjust its scale to fit the size of the particle. We change its color based on the particle's transparency and darkening value. And finally, we apply a random Z rotation to create some variation. When all the necessary information is depleted, we kill the particle to make it disappear. However, one problem still persists. As you might have noticed, our blood splatters exceed the edge of our panels, which totally breaks the illusion of blood getting painted on the ground. To fix this problem, we make use of sprite masks. By applying a mask to our ground panels, we can force the splatters to only render within their bounds, which completes the illusion we were going for. With this, our blood splattering system is now officially implemented inside the game. Stay tuned for our next episode where we'll create art assets for our blood effects. Make sure to like, comment and subscribe, and we'll see you next week for the new episode of our Road to Steam series.
Skulle